In this video, we'll look at question 54 from the 2016 exam. The ball is hanging from the ceiling, attached to it by a rope, until a horizontal 30 Newton force is applied to it. And when that happens, it finds a new equilibrium position, here in darker black. And we are supposed to find the change in gravitational potential energy between these two positions, given that the length is 0.35 of this cord and the weight of the ball is 40 newtons. So in order to find the change in gravitational potential energy, we'll need to know this distance x, the difference between the initial and the current heights of the ball. That, along with its mass, are the only two variables on which the gravitational potential energy depends. It will in fact be just the weight, 40 newtons, times this distance x. So now if we label this angle here as theta, it must be that x is the whole length of the cord, 0.35 meters, minus just this section, which is the projection of the darker cord, 0.35, times cosine of theta. So that's x. So why don't you try and find theta yourself? This angle is in fact given by the magnitudes of these two forces. The resultant force will be in this direction like that, and we'll have magnitude given by Pythagoras, and because it's a Pythagorean triplet, it's 50 newtons. It's 30 squared plus 40 squared, and square root of that is 50 newtons. And the tension, which is always along the string, will have to pull in the opposite direction as to keep the ball in place. And because it is always along the string, the direction of this force gives us also the direction of the string with respect to the vertical. So the angle theta from here can also be found between the two forces like this. And if I redraw this triangle a bit more neatly, it is clear that cosine of theta from this triangle will be 40 divided by the length of the hypotenuse, 50, which equals 0.8. And what that means for us is that x is 0.35 times 1 minus b is 0.2, which is 0.07. It's 1/5 of 0.035, of course in meters. And we can now combine that with the first formula for the gravitational potential energy, which tells us we need to multiply this value of x by 40. So 40 times 0.07 is 2.8 joules. And that's our final answer, and in the exam, it was option B.